Hello! In this video, we will learn about principal stresses and Mohr's circle. In the problem shown, we are asked to draw Mohr's circle given the plane stresses sigma x, sigma y, and tau xy. First thing we need to do is to set up a traditional coordinate system with the x-axis being in the horizontal direction and the y-axis being in the vertical direction. Then we can proceed by drawing a stress element, which can be represented by a small square, and show the plane stresses sigma x, sigma y, and tau xy. So sigma x is equal to 9 megapascals, and sigma y, since it's negative, it's a compressive stress, we can show it on the stress element like that. So sigma y is equal to 6 megapascals. We can drop the negative sign because we already showed that sigma y is a compressive stress. Now you might be wondering how to draw tau xy since it's clockwise. CW stands for clockwise. So let's take this plane right here, the positive x plane. So the positive x plane, and tau xy, since it's clockwise, by sign convention it should be negative. So if we draw tau xy on this plane like that, tau xy, it's going in the negative direction, and if you multiply positive by negative, you'll get negative, which is what we want since it's clockwise. So let's practice on this face now, the positive y face. Since it's a positive face, tau xy should go in the negative direction to produce a negative result. This face right here, the negative x face, it's negative. Tau xy should go in the positive direction to produce a negative shear stress. And lastly, for fourth face, which is the negative y face, tau xy should go in the positive direction, like so. So after drawing the stress element, we can proceed to find the principal stresses, which can be found using this formula. So sigma 1 comma 2 is going to be equal to sigma x plus sigma y over 2 plus or minus square root of sigma x minus sigma y over 2 squared plus tau xy squared. And one important formula we have to use is C, the center of Mohr's circle, which is equal to sigma x plus sigma y over 2. So these are the important formulas we have to use to draw Mohr's circle. So let's proceed by finding sigma 1, the first principal stress. So sigma 1 is going to be equal to sigma x, which is 9, plus sigma y, which is equal to negative 6, so minus 6 over 2 plus square root of sigma x, which is 9, minus sigma y, negative 6, over 2 squared plus tau xy, which is negative 3 squared. Remember, we plugged in negative 3 because tau xy is clockwise, and clockwise, by following sign convention for Mohr's circle, clockwise is negative. I know it doesn't matter if you plug in negative or positive since it's squared right here, but nonetheless you should follow the sign convention. So this is sigma 1, sigma 2, it's going to be the same thing, 1.5 minus this term right here, which is 15 over 2 squared plus negative 3 squared. And the center, C, is equal to sigma x plus sigma y, so 9 minus 6 over 2, which is 1.5. This is the center. For sigma 1, the principal stress 1 is equal to 1.5 plus 8. So it's going to be 1.5 plus 8.08, which comes out to be 9.58 megapascals. And for sigma 2, it's going to be 1.5 minus 8.08, which is equal to 8.08. That's going to be negative 6.58 megapascals. So once we found the principal stresses and the center, we can proceed to draw Mohr's circle by setting up the axes. So the horizontal axis is going to be sigma, and the vertical axis is going to be tau. So sigma 1 is equal to 9.58. Since it's positive, it's somewhere right here. 9.58. This is sigma 1. Sigma 2, since it's negative 6.58, so it's somewhere, let's say here, negative 6.58. And the center is 1.5. So it's somewhere here, 1.5. So if you connect the principal stresses, like that, you're gonna create Mohr's circle with tau max being right here. This is tau max, which can be found using this formula. So tau max, if you want to find the maximum shear stress, it's going to be equal to sigma 1 minus sigma 2 over 2. Now let's think about this formula for a second. Sigma 1 is right here, 9.58, and sigma 2 is right there, my negative 6.58. So if you subtract sigma 2 from sigma 1, you're gonna find this distance right here, which is the diameter of Mohr's circle. And if you divide the diameter by 2, you're gonna find the radius of Mohr's circle, which is, in this case, it's gonna be equal to 8.08 megapascals. So this is tau max. This is the first principal stress, second principal stress. This is tau max right here. So the problem is asking us to also determine the angle from the x-axis to sigma 1. So let's look back at the stress element. This is the x face right here. Has sigma x 9 megapascal and has a shear stress of 3 megapascal clockwise. So if we go to Mohr's circle, the x face has a normal stress of 9. So it's somewhere here. It's less than the principal stress, it's 9. And tau xy, it's going clockwise. Remember, this tau right here, for the positive y-axis, it's going to be clockwise, and tau for the negative y-axis is going to be counterclockwise. So since the x face has a tau xy of a clockwise shear stress, you're going to go up clockwise. So 9 for sigma, 3 for tau. So this is the x face on Mohr's circle. 9 for sigma, 3 for tau clockwise. Now you can connect the radius from the center. So this is the radius, and this is 9 right here for sigma. Now the problem is asking us to determine the angle from the x-axis to sigma 1. So this angle right here, this angle right there. So this angle is 2 theta p. So 2 theta p. And you might be asking, why 2 theta p? Because on Mohr's circle, angles are doubled. So whatever the angle is on Mohr's circle that you calculate, you have to divide by 2 to find the real angle for the stress element. So let's find 2 theta b. So if we do tangent 2 theta p, it's going to be equal to opposite, which is this one right here, the opposite, 3, equal to the shear stress, over this distance right there, which is 9 minus 1.5, which is 7.5. So this angle comes out to be 10.9 degrees. So 10.9 degrees, if you want to go from the x-axis to sigma 1, right here. From the x-axis to sigma 1, you have to rotate by this much. You have to rotate the stress element by 10.9, and since we're going clockwise, you have to rotate the stress element. So here's our stress element, like that. This is the x direction. This is the y direction. Since we went clockwise on Mohr's circle, we have to go clockwise here. So if you do this, this is our new stress element, which we rotated by 10.9 degrees. Let me show that more clearly. So 10.9 degrees, and the x-face has sigma 1, because remember this is the x-face going to sigma 1, so sigma 1, and the y-face, which is right here, this is the y-face going to principal stress 2. So the y-face has a compressive stress of sigma 2. And that concludes our problem. Thank you.